In a paper titled Neural Algorithms of Artistic Style, published in August 2015, Leon Gattis discussed neural style transfer, which can be used to learn styles from famous artworks by famous artists and apply to regular photos. Previously, we have known that lower hidden layers learn lower level features such as edges and plane textures, while deeper layers learn more fine and high level features. Using transfer learning, some hidden layers could be reused and used to create a new model. The reused layers can generate feature representation of the input images. Examples for pre-trained networks include VGG16, VGG19 for 19 layers, and VGG16 for 16 layers. DenseNet, Inception, etc. So what it does basically is that neural style transfer merges a content image C and a style image S in order to create a generated image G. The generated image G is created in a way such that it has similar content as the input image C. So let's say we have the image, the content image C and the generated image S, the generated image G and the style image S. We send them through the convolutional layers of a pre-trained model. So AC and AG are the layer activation at a layer at some level in the structure of the network. We calculate the cost function. This cost function is calculated at layer L for the content image, and basically we measure how much the content image is different from the generated image. And this is the sum of squares, and the term in front is just the normalization term of the cost function. So when we try to minimize the content cost, which is to make the generated image approximate the content image in terms of content features. In this figure, we have the content image. We can initialize the generated image or the composite image with the content image so that we can make it quick. We send them through the pre-trained layers, and we decide that at this layer, at this level, we extract the features, and from there we get the cost function. Note that this has to be done across all the channels. Now we talked about style cost. Style cost for a specific layer L is defined by the function J. And basically it measures how much the style image is different from the composite or the generated image. Looking at the illustration on the top right corner, we have the generated or the composite image on the left and the style image on the right. Sending the images through the pre-trained network, and we decide the layers at which we calculate the style cost for example at layer 1 and layer 3. We can do also layer 2 as well, and then we sum them all together, sum all the cost together. And that's how we get the combined style cost, which is calculated as the sum, the combined style cost for all the layers from 1 to L. And eventually we add the content cost and the style cost together. Now go back to the example that you saw previously. We have the content image, which is about a mountain area, and the style image, which is a foliage scene. We can learn the style from the style image and apply to the content image and make it a composite image that looks just like this. And this is the whole picture of how we get the content cost, the style cost, and the total cost, and how the generated or the composite image is updated. We can use any pre-trained convolutional neural network. For example, VGG16, VGG19. So as mentioned, we selected the second layer, the second convolutional layer, to get the content features, which are the activations. Also select the activations of other layers for the style cost. In this case, we selected layer 3 and layer 1. We have the content image. We initialize the composite or the generated image as just using the content image. And we have the style image. We forward propagation. We do forward propagation for all those images through the network to compute the content cost and the style cost. Right? And sum them all together, we get the total cost. So the solid lines show the forward propagation, and the dotted lines show the backward propagation. We use the back propagation to update the composite image, and eventually we output the final composite image. There are some more examples for neural style transfer in the paper Neural Algorithms of Artistic Style by the author Leon Gattis. At the top left corner, it is the original photo, and this is the content image. Depending on which style image you apply to, you may get a different generated image. So in B, the style is from the artwork, namely the shipwreck of the Minotaur by Turner in 1805. And this is what you get. This is what you get when you apply the style to the photo. In C, the style image is The Starry Night by Van Gogh in 1889. So applying the style from Van Gogh's artwork, the image looks like the photo, then transferred, getting the style looks like the painting created by the artist, by Van Gogh. In D, the style is, this style is Dear Sri by Edward Munch in 1893. Other style images are by Picasso in 1910 and Wassily Kandinsky in 1930.